Hi guys, today we are going to solve problem number 2244, that is minimum round to complete all the tasks. In this problem we have been given a task array and it contains various tasks. What this task array represent is the difficulty of the tasks, like level wise. And in each round what we can do, we can either complete two tasks or three tasks, only either two or three tasks of same difficulties, like the difficulties of this task should be of same level, and we can either pick up two tasks of same difficulty level or three tasks of same difficulty level, neither less than it nor more than it. Okay, so either two or three tasks we can pick up of same difficulty level. So the ask of the problem is we have to return the minimum rounds required to complete all the tasks. So just by reading this word when minimum, it gives us a sense that we have to somehow apply greedy algorithm here or greedy approach here, right? Now, uh, this thing is clear that if the tasks are given of various difficulty levels, what we have to do as an initial intuition is like we have to find the count of each of the difficulty level of the task, right? So, like we have to create a map so that we can know what are of a particular difficulty level, how many tasks are there. So if you look at it, for 2 here is actually 3 tasks are present, right? For 3 difficulty level there are only 2 tasks are present, and for 4 difficulty level there are 5 tasks are present. So something like this we have to create a map, right? So that we can know of each difficulty level how many tasks are there, right? So once we have reached this level, now the second thing that we have to figure out is like how many rounds will be required to complete these tasks, right? Or to be put it in another or a simpler way, is it would be something like this, like all these counts that we have got for each of the difficulty level, how efficiently we can group them together, right? Or how greedily we can actually group them together. So let's see how we can actually group it in a more efficient way. So up till now what we have done is like we have created a map like this, right? Where it represents like the level that we have and what is the count of tasks associated with those levels. Now, if we get these counts right, so if we are able to generate some formula, some intuition, with the help of which we are able to identify like what how much efficiently we can actually group this value into a group of either twos or threes, right? Then we'll be able to solve this problem. Now in the problem what we have been given is like we can only group the task in group of either two or three. So if the count of any particular value is less than 2, like that is like something like 1, so in that case the answer is not possible and we have to simply return -1. So in this map, if there is a value like 5 and it has count as 1, then simply we just have to return -1, that it is not possible to group, right? Now let's say we have any value greater than it, right? So if we get any value like 3, 5, something like this, then what we can do? So if we are thinking in the direction of greedy, so what we will try to do is like always try to group them into larger size so that the number of rounds is less, right? So that's how we are thinking. Now what will happen is like let's say we have uh, 5, like 5 count of twos, like so what we'll always try to do is like always categorize them into group of 3, and whatsoever is the remaining, then we will think about it, right? So but always what we will try to do, first group into a size of 3. So once we have grouped it into size of 3, so from here we get one group, and since the remaining group are 2, and this is also possible because we can create group of size 2 and 3. So this is a group of size 3, this is a group of size 2, so 1 plus 1, these two group are there, so answer would be 2, right? So Like this is the greedy approach. Simply divide it by 3 and then see what are the possible outcomes, and based on that we can do the grouping. Now let's say there is a number, like there is a number x. When we divide x by 3, what are the possible outcome that we can get, right? When we divide a number by 3, there are three possible remainders that we can get. Either the number is completely divisible by 3 and the remainder is 0, or the remainder is 1, or the remainder is 2. If the number is completely divided by 3, like we have one more 2 here, so they are completely forming a group of 3's, and we have two groups, so we can simply return x by 3, right? So that will be our answer. And the second case, like let's say we are getting a remainder as 2. In that case also, like as I discussed this example earlier, so let's take 5 2's. In this case what will happen is, like, we can form a group of 3, right? And then what we can do, we can another form a group of 2, because forming a group of 3's and 2's are allowed. So what we did is simply divide whole the count by 3, like x by 3, and simply added 1, because this is another group of size 2, right? But that is also again the case when we get remainder as 2. So in this case what we did x by 3 plus 1, right? Now what to do in case like the remainder is 1, right? What to do in case the remainder is 1? So let's take an example here. So we have like uh, 4 2's, right? And in case of 4 2's, what we will try to do is, like, we again simply divide a group of 3, like doing it greedily, and then after that we are left with only 1 2, right? 1 2, but this is not allowed, right? We cannot form a group of size 1. But if you think about it, like if we give 1 2 from this group of 3 to here, then what will happen is, like, this will form a pair and this will form a pair, right? And again, this is allowed, a group of size 2 and a group of size 2, so this is allowed. But again, if you think about what should be the formula, so the formula is still the same, right? When we did initially, we have size of 4, we divided that particular 4 by 3, right? And then we are left with 1 plus 1. Why we did plus 1? Because this pair of this group of 3 actually can get internally 1 2 to here, and it will form a pair of 2 2's, right? So that's why with that it will still give you the value as two groups. So again, so here the formula would be x by 3 plus 1, right? So let's see with this how many cases we are actually able to derive, right? So in case the value comes as 1, so if the value is 1, then simply return as minus 1 as answer. If the value is divisible by 3, right? If the value is divisible by 3, then simply return that value by divided by 3. And if this is not the case, right, if it is not divisible by 3, then in both the cases, then we have to simply return x by 3 plus 1, right? Where x can be any value present from these values, right? So yeah, that will be the answer. So let's see the code, how we are going to implement it. So the code wise, it's pretty much straightforward. As we discussed, first we have to create a map. In each of the map we will count the number of tasks of each of the difficulty level. So that's what we are doing in this line, right? Then if we discuss, like, then what we'll do, we'll iterate all the values of the map. So we had created a map like this, right? So we will iterate all the values one by one. Like we can have 5 4 1. So in case we get a 1, simply we have to return minus 1, like it is not possible to categorize it. But if that particular value right, and if that is not the case, we will go into the else block. And if that particular value is divisible by 3, so that will be the answer. And if that is not the case, so we have two scenarios, like, right, if we divide a number by 3, we have three scenarios: 0 remainder, 1 remainder, or 2 remainder. So if the remainder is 0, we simply return divide the number by 3 and add it to the answer, right? And if that is not the case, so we have these scenarios. In both of these cases, the answer would be x by 3 plus 1, right? So that what we are doing here. And once we iterate over all these values, we are adding the value to the answer with these formula, right? And eventually in the end, we are returning the answer. So that's the whole approach, and I hope you are able to understand the problem. So thank you very much.